Part A of practice problem number 1 asks students to write a second equation so that the system of equations has infinitely many solutions. What that means is to write a second equation that's equivalent to the first equation. So how does one write an equivalent equation? I took the easy way out when I first did this problem, in that I just wrote a second equation that has a slope that's the same, but it's just written as an equivalent fraction. So negative 3/4 is equal to a negative 6/8. So these two equations are equivalent. Same y-intercept and same slope. But what if we make this a little bit more difficult? So here's an equation. This equation is in fact equal to this equation on the right. And I'm going to show you how I wrote this equation in a little while. But let's go through and prove that this equation is equivalent to the equation on the right by simplifying this expression right here. So the first step I'm going to take is I'm going to write these expressions equal to each other. This is using the transitive property. If y is equal to this expression and at the same time y is equal to this expression, then both of these expressions are equal to each other. And so now I can go through and use mathematical properties to simplify this expression on the left. And what I want to do is get this to where all of the terms of x, all the x terms are together, so they're collected together in a single term, and that's going to equal negative 3/4 x when I get there. And all the numbers without any variables are collected into a single term as well, and that's going to equal a positive 4 when I get there. These two terms cannot be added together because they are different things. So this is the simplest form that you can get this expression to. So what are the steps to get there? First, I'm going to move these x's next to each other. That's using the commutative property. So if I move this 2x over to here and move this 7 over to here, I'm going to just have them switch places. That is the commutative property. And at the same time, I got rid of these brackets here, these brackets, by using the distributive property, 3 times 7 and 3 times a negative 8. So that's using the distributive property, so I'm moving towards a simpler form. So now I'm going to combine these x terms, so negative 2 and 3/4 plus a positive 2, well, that equals a negative 3/4. So this is going to equal negative 3/4 x. That's this negative 3/4 x right here. So that's collecting like terms. So I'm collecting the x's together, and now I'm going to collect just these numbers together. So 3 times 7 is 21, and 3 times a negative 8 is negative 24. That equals negative 3, and 7 plus negative 3 is equal to 4. So that's, again, collecting like terms to get this down to the 4. And so these two expressions are the same. So I could stop there and say that the equations are equal. But let's go a step further and let's solve this equation for x. So what do we get when we solve for x? First thing I'm going to do is get rid of this 4 by adding the additive inverse. So the additive inverse of a positive 4 is a negative 4. So 4 plus a negative 4 is 0, so it's left with a negative 3/4 x. On this side, same thing, negative 3/4 x. So that's using the additive inverse. Now I want to get rid of this negative 3/4 as the coefficient. The number that goes along with the variable is called the coefficient. So I'm going to use the multiplicative inverse to get rid of that negative 3/4. So I'm going to multiply by negative 4/3. This equals 1. So this will equal 1x, which equals x. So that's using the multiplicative inverse, negative 4/3, and negative 4/3 times a negative 3/4 in both cases. And you end up with x equals x. So what that means is that whatever value I choose for x in either equation, I'm going to get the same value for y. So these equations are equivalent. Remember, this whole process is called simplifying the equation or simplifying the expression. Just getting this to where you just have a single term of x's and a single term of just numbers. And terms are separated by addition. Okay, I do want to show that these two equations are equal to each other. So here's a graph of the first equation. So the y-intercept is 4. The slope is a -3/4. So for every 4 units along the x-axis, this graph goes down 3 units along the y-axis. So it's a -3/4, -3/4. And so here's the second equation. So if I choose a value for x, I'm going to choose 4 right here. I should get an answer of 1, because the point 41 is on this line. So if I replace x with 4 and work through the arithmetic, 4 times the -2 3/4 is -11, plus the 7, plus 2 times 4 is 8, plus 3 times -1. 7 plus -8 is -1. Continue to work through this. You get a -11. This is positive 15 here, so that equals 4. And this equals -3. 4 plus -3 is equal to 1. So I do get this point right here. X is 4, y is 1. So if I use 4 for x up here, I should also get y is equal to 1. And I do. So 3/4 of 4 is a -3/4 of 4 is -3, plus 4 is 1. So whatever value I choose for x, if I use either equation, I'm going to get the same value for y. So these two equations are equivalent, and they have infinitely many solutions. And I had said before that I took the easy way out, where I just wrote an equivalent fraction. And it was -6/8, which is equivalent to -3/4. So let's make this a little bit more interesting. Okay, so I want to write an equivalent equation to this equation, this first equation, but I don't want to just use an equivalent fraction. I want to use something different. I want to make it a little bit more interesting. So I'm going to look at both of these terms, the -3/4 x and the +4 separately. I'm going to expand them out to a plus b. And so a plus b equals -3/4, and a plus b equals 4. And so now I can figure out some values for a and b in both cases and just put everything back together, and I will have an equivalent equation. So say I choose 2 for b. So that means that a has to equal -2 3/4. So here's two values I can use to expand this -3/4 x. And let's do the same thing on the right side. Let's choose a is equal to 1/4. That means that b has to equal 3 3/4, because 3 3/4 plus 1/4 equals that 4. So now I have some things to work with. I have this -2 3/4 x plus 2x. So that -2 3/4 plus 2 equals this -3/4. This gets a little bit convoluted, a little bit hard to follow, but it's worth practicing. It's worth going through the arithmetic, the algebra, to convince yourself that you know what's going on. So this is plus 1/4 plus 3 3/4, because 1/4 plus 3 3/4 is equal to 4. So now I can set all of this equal to y, and that equation is equivalent to this first equation up here. But I made it a little bit tougher in that I moved this 2x over to the other side of the equal sign, the other side of the equation, just by subtracting this 2x from the right side and subtracting this 2x from the left side. So y minus 2x equals all of this. And I even made it a little bit tougher in that I used the distributive property. So actually the way I thought about this is if I double y to 2y and I double 2x to 4x, then I have to multiply each of those by 1/2 to get this term, to get this expression back. So that's using the distributive property. So 1/2 times 2y minus 4x is equal to y minus 2x. So all of this is equivalent. All of this is the same. So this equation right here is equivalent to this equation up here. although it looks very different. Okay, so let's try something a little bit different. Now I know I'm getting way out there, and there are many, many different ways to do this. I'm just trying to show students a couple of different ways to write equivalent equations, because the authors don't show the students how to do this. It's not something that's really regularly taught, but it's something very useful to practice. So I'm going to start out with the left side being the same, but on the right side, I'm going to write two terms here that have a common factor. So I'm going to you can choose anything. I'm going to choose 21 and 24. The common factor is 3. To make this a little bit more difficult, I'm going to make this a negative 24. Common factor is still 3. So I'm going to factor out that 3. So 21 divided by 3 is 7. And a negative 24 divided by this 3 is negative 8. So notice that 3 times negative 1 is negative 3, and 21 plus a negative 24 is also negative 3. So this hasn't changed at all. But this side is equal to negative 3. This side is equal to 4. So negative 3 plus what value equals 4? Well, negative 3 plus 7 equals 4. So all of this is equal to negative 3. And so I have to add 7 to that to make this equal to 4. Remember, I have to get this equal to 4 up here. All right, so now I can use this expression right here. I have to add the 7 to it, and I can use these two expressions over here. So I can use the 2, I can use the negative 2 3/4. I can use the 3 times 7 plus a negative 8. And I have to add, remember, I have to add the 7 to that, because this right here is equal to negative 3, so I have to add this 7. So now I can put that all together. Y is equal to a negative 2 3/4 x plus 2x. Remember, this part right here is equal to this negative 3/4 x, and plus all of this is equal to the 4. So 3 times 7 plus negative 8 plus 7 equals 4. So that's equal to the 4 right here. And so I made this a little bit tougher, and then I moved this 7 using the commutative property. I moved this 7 to further inside this expression. So I moved this 7 over to here. So this is the original equation that I started with early on in this video. And this is how I wrote it. So this is an equivalent equation to y equals a negative 3/4 x plus 4. Okay, this is probably the most obscure part of this video, in that you oftentimes see equivalent equations that are using the distributive property that equal something that does not include the distributive property anymore. And it took me a while to figure out how to write that, how to do that. So what I did is I just decided I'm going to pull this negative 3/4 out of this expression. I'm just going to write this in parentheses. Now these two expressions are not equal to each other. This is equal to negative 3/4 x plus 4. This is equal to negative 3/4 x plus negative 3, because a negative 3/4 times 4 is negative 3. So they are different. So if this part equals negative 3, what do I have to add out here to make this expression equal to this expression? Well, negative 3 plus 7 is going to equal this 4. So remember, this part right here is equal to negative 3/4 x plus negative 3. Then I have to add this 7 out here to make this whole thing equal to negative 3/4 x plus 4. Because 7 plus negative 3 is equal to that 4. So now if I just move this, adding the 7 up to here, so now both of these are equivalent, but this looks very different. This is now using the distributive property here, and then you're adding this term out here. So if I simplify either one of these, I'm going to end up with negative 3/4 x plus 4. This is where we started. And so if I set y equal to this expression up here, and then all I did is I moved the 7 over to the other side of the equation by subtracting 7 from both sides. So y plus a negative 7, or you could say adding a negative 7 to both sides. 7 plus a negative 7 is 0, and y plus a negative 7 it becomes the left side of the equation. So this is the equation. Y plus negative 7 equals a negative 3/4 x times x plus 4. And this equation is equal to this first equation up here. A little bit more obscure. Take some practice.